Okay, now we're going to do a lesson on Pascal's triangle and binomial expansion. First, what we're going to look at is the expansion of a binomial. Well, a binomial is a sum or difference of two terms. Okay, so for example, if you got x plus y, well, that's a binomial. And that's your most basic binomial. When you're expanding it, what you're doing is, if this is to an exponent, like 2 or 3 or 4 or whatever, you're multiplying it out and collecting like terms. And we're going to look for a pattern while doing this. So the first one we're going to look at is x plus y to the 0. Well, anything to the 0 from our exponent laws is 1. Okay, so if we've got x plus y to the 0, well, we just get 1. All right? And the next one we're going to look at is x plus y then to the next higher exponent, which is 1. And if we do that, well, anything to the exponent 1 is itself. 3 to the 1 is 3. 7 to the 1 is 7. And so on. So that's just x plus y. And then, so we've got that one there. Okay. Then we're going to look at x plus y squared. Well, what a lot of people want to do on this is just say that that's x squared plus y squared, and that's simply not true. Okay, we know that x plus y squared is x plus y times x plus y, and when you expand this out, we use FOIL, and it's a perfect square as well, so you get x squared plus xy plus xy plus y squared. Okay, so outside, first, outside, inside, and last. Okay, collected like terms, you get x squared plus 2xy plus y squared, and this is the form of our perfect square. So we should know this. Okay, so now we got x plus y squared. Okay, and maybe you're seeing a pattern at this point, maybe not, I'm not sure. The next one we want to do, okay, is x plus y to the 3. Well, for x plus y to the 3, you're going to have to write it out as x plus y squared times x plus y. And you might want to pause at this moment now and try to expand this out. Note that we have got x plus y squared already here. Okay, so that would equal x squared plus 2xy plus y squared all times x plus y. Okay, so when you expand that out, what would you get? Okay, well, when you expand that out, you're going to get this one right here, x cubed plus 3x squared y plus 3x y squared plus y cubed. Okay. Now, then if you're going to do x plus y all to the power 4, or the exponent 4, you're going to take this answer and multiply it by x plus y. Okay, so you might want to pause and try that and see what you get. Okay, so if you've tried it now, then you can take a look at this. So x plus y to the exponent 4 looks like this. Okay, so now we can start taking a look and see if we see a pattern. Okay, so you see a pattern here. Well, the first one starts off with a 1, and then you've got x plus y, then x squared, y squared. And you notice whatever the exponent is here is kind of the exponent of x and y here. So it's basically 1 there, and then x to the 1, y to the 1, x to the 2, y to the 2 here, x cubed, y cubed at the end, x to the 4th, y to the 4th at the end. So if you had to predict for x plus y to the 5, you might say that the first term is going to be x to the 5th, and the last one would be y to the 5th. But what's in the middle? Well, you might also see that this is a 2 here, so that's this exponent 2, there's a 2. There's a 3, there's a 3 and a 3. Okay? There's a 4, well, there's a 4 and a 4. Now, how do you get that middle term? Well, maybe how did we get these other terms, okay? Well, if you look above, the 3 plus 3 gives you 6. Now, if you expanded x plus y to 5 out, okay, you would get this. Okay, x plus y to the 5 would be this. And if you look at the pattern that I'm trying to indicate to you, okay, so it starts with 1s on the outside, or sorry, the number x to the 5, y to the 5 on the outside, goes up to that. Then we got a 5 here and a 5 here. Then we got a 10 here and a 10 here. Well, the 6 and 4 add to 10, just like 3 and 3 added to 6. Does this work for the other terms? Let's take a look. Well, 1 plus 1 gives you 2. 1 plus 2 gives you 3. 1 plus 2 gives you 3. Where did I get the 1 from? Well, the 1 is right in front of the x squared. We just don't write it. 1 plus 3 gives me 4. Okay. 1 plus 3 gives me 4. We always start off with a 1 in front of these. Then 1 plus 4 gives me 5. And 4 plus 1 gives me 5. And from that, you might be able to predict what the next one is. So you can pause, try and make that prediction, and I'll show you in just a second. You've got to also look at the exponents in here. What happens to them? Well, hopefully you notice that the exponent of x starts at 5, then goes to 4, 3, 2, 1, and the exponent of x here would be 0, basically. So as the exponent of x goes down, the exponent of y goes up. So that each time the totals of these exponents is 5. So 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and 5. Okay? So now, if you've paused and you've tried the next one, here's what that next one looks like. Okay, so that's what that would expand to. And you should now be able to get the next one based on this pattern. So 5 plus 1 is 6, 10 plus 5 is 15, 10 plus 10 is 20, 10 plus 5 is 15, and 5 plus 1 is 6. Keeps going like that. These numbers happen to fall into a pattern that was discovered some time ago. It's called Pascal's Triangle. Okay, so I'm going to list these coefficients and we're going to name that. So Pascal's Triangle looks something like this. Starts off with a 1 and then goes 1, 1. Numbers on the outside are always 1. Then the next level goes 1 again, and then these two add up to give me 2, and there's a 1. And then next level is 1, and then these two numbers add up to give me 3. These two add up to give me 3, and then it ends with a 1. And then the next level, 1, 4, 6, 4, 1. Okay. And the next level is going to be 1, 5, 10, 10, 5, and 1. And then I'm going to do one more so we can match our problem above. So 1, 6, 15, 20, 15, and 6, and 1. Okay, so that goes up to as high as you want. You can keep going in this triangle. But this matches, this last row here matches expanding x plus y to the 6. So 1, 6, 15, 20, 15, 6, 1 are the coefficients of the terms in this expansion. So that tells you how many terms there are in this Pascal's triangle. Okay, so x plus y to the 6. So that's to the 0, to the 1, to the 2, to the 3, to the 4, to the 5, to the 6. And you go 7, and so on. Okay, so this is Pascal's triangle, and if you follow the basically the exponents dropping here by one each time for x, and going up by 1 each time for y, until you get to the end, you'll get the variables in here, and then you've got the coefficients using Pascal's triangle. So let's see if we can do something